Good morning, good afternoon, or good evening. This is the Antrea committee meeting. Today is Tuesday, March 29, 6 in the morning, Central European time. If you are instead in the Pacific West Coast, it will be still Monday for you. And let's start with today's meeting. So today we have a very nice agenda. We will start with an introduction with a discussion from Grayson about ICMP supporting network policies. And then Lan will provide also a discussion of data path for multi-cluster networking. So since we have a very packed agenda, I think it's time for me to stop talking and let's start with the presentations. Grayson, would you like to go first?
Yeah, sure. Thanks, Arthur. Let me. Can you guys hear me?
Yes, I can.
Okay. Let me share my screen. Okay. You guys can see my screen now, the slides.
Yep.
Okay. So today I will show you the ICMP support in Antrea network policy, and this is today's my agenda. First, I will go through the motivation, and then the API proposal, and the controller side change and agent side change. And also I have, since the development is almost done, so I have a demo video for you guys. And then it's the Q&A section. So for the motivation, we all know ICMP is a very commonly used protocol, and especially for use it for debugging. And also we already heard some complaints about we're not supporting ICMP, and this is the GitHub issue about the requirement to have the ICMP support. And another reason is some CNIs like Calico, they support ICMP in their network policy. So we want to support ICMP in ours. For API proposal, this is our current API. If we want to define a policy on some specific protocol, we have a field called ports, and we can define the ports, protocol, ports, and import. Currently only support the TCP, UDP, and the SCTP. Yeah. And if you want to, for example, matching all TCP traffic, you can define a policy like this, only define the protocol without ports. And yeah, I guess we are familiar with this, so I will go to the proposal. So we have some discussion about this. There are several options. For example, this one is if you want to keep the backward compatibility, we add a field called ICMPs, and it contains the several fields called like match all ICMP type and ICMP code. In this way, the currently user won't be affected since the ports are still here, and this is the network policy port struct. We didn't change this struct. Let's see the example. If we want to, for example, match all ICMP traffic, the rule will look like this. And for example, we want to match the ping request, the rule will look like this. And if we want to match, sorry. Basically, the ports are still the same usage as before. But this way, it's not that extensible, since if we, for example, want to add IGMPs in the future, we will add another fields under the rule. It's not that good, I guess. So there's another options, like we change the name of the ports to services and add this spec for different protocols under this network policy service struct. But this one, like, if we name this as services, it's kind of like confused, since the user might think, hey, this something related to the Kubernetes services. So yeah, this is an example, but we also like give up this proposal. And finally, this is the current one we want to pick. We changed the ports to another field name called protocols, and under the protocol, you can add the protocol that we supported. If we want to like support IGMP, we can add another field in this struct, and the different struct may have different spec. They can use different like their own struct to define their parameter like SMP type, and for L4 protocol, they have port and endport. And since this will change the the old API, so it will require us to bump our network policy version to V1 Alpha 2, and we add a convert function to translate the to convert the V1 Alpha 1 policy to the V1 Alpha 2 policy, mainly change the ports to the protocol. In this case, user using the older version API won't be affected. And this is like some example, like if we want to match all TCP traffic, we can define a policy, a rule like this. And if we want to specify the port of TCP, you can define a policy like this. And for ICMP, you can do things like this. So yeah, this is the API proposal. So if we go with this one, by the way, if you guys have any questions, feel free to interrupt me at any time. Yeah. So if we go with this API proposal on the controller side, we bump up the API version and add the conversion function, as I said. It's mainly change the ports to protocol, and in this case, there will be no impact. And also for the internal MP, we can add the ICMP type and the ICMP code here. When the agent receive the this internal network policy, it can have a corresponding like action on these two fields. So it's not too complicated on the controller side. So for
Grayson, I have a question here.
Yeah, go ahead.
For the second item, does this convert function means a Golang function or some conversion webhook in Kubernetes?
I guess it's same like the how we do the cluster group convert. It's written in Golang, and I guess it's a webhook. So the controller, when the controller receive, go ahead.
Yeah, please go ahead.
Yeah, when the controller received, it's already being translated to the V1 Alpha 2 policy.
So which component is responsible for this conversion? The Kubernetes API?
Yeah.
Okay. So I don't remember the implementation detail. Then which version it will store for this API?
V1 Alpha 2.
And then what happens to the V1, the existing V1 Alpha 1 object? Will they?
This is a good question. You mean like it has already have some V1 Alpha 1 policy, and then the user, for example, update the Antrea, right? You mean what happened to the existed V1 Alpha 1?
I guess if user updated it, maybe the API server could convert it to new version and store the new version. Right? But what if user doesn't update it? What will happen?
if I may answer this question, from what I remember is that it doesn't really matter, because in the internal storage, it will always be v1 alpha 2. And it was only when user tried to get the object specifically using v1 alpha 1, then the reverse conversion will happen. And the v1 alpha 1 object will be returned to the user. Otherwise, everything will be basically converted to v1 alpha 2, and the storage on the wire to the controller, everything will be v1 alpha 2.
Yeah, I get it. My question, I have another question, is when we can remove the v1 alpha 1 version if the existing object is not changed after we have this version 2. If does that means we will have to support alpha 1 forever?
I'm not sure if I understand your question. You mean like you mean like? Yeah, go ahead.
For example, I create a v1 alpha 1 object and upgrade to new Antrea version. Now I can use v1 alpha 2 and v1 alpha 1. But if I don't update the objects I created before upgrade, I guess the existing object will always be stored as v1 alpha 1 in storage, right? Then when we can remove the support for v1 alpha 1, I mean, if we just keep them forever, but it might be okay. But what if we bump another version later? Does it mean we need to support 3 versions and perhaps beta version, version and GC version, GA version? I mean, maybe this is not specific to this bump up. I just want to understand how we handle this API version change and deprecation policy.
I definitely needed to double check this, but from what I remember, the scenario you just brought up, when we have the Antrea upgrade, I would assume that after the upgrade, the original created object will already be stored in v1 alpha 2 in storage, not in v1 alpha 1.
If we want to deprecate the v1 alpha 1, we should do this mirror controller approach we did before. That means
we
yep. Go ahead.
I just want to go ahead. Yeah.
We don't necessarily need to do that because the mirror controller is in place because we have 2 entirely different API groups. But for version bumps, there was a common practice where Kubernetes imposes on, and it was specifically used to handle cases like this. So from what I remember is that we can specify a specific time period. We can just warn people that this is supported for now. You can continue to use v1 alpha 1, and when you upgrade, it will automatically internally be v1 alpha 2. But at some point, we'll be dropping the support for v1 alpha 1, and it shouldn't basically affect the users in any way. So for the new resources, you can no longer create v1 alpha 1, but for the old resources, internally, they are already converted to v1 alpha 2 based on the conversion function provided to the API.
I remember in Kubernetes docs, you mentioned some standalone program could have to list to handle this scenario, I remember it lists all existing objects and then make a dummy update to make the stored version to be upgraded. Not sure whether it is improved now or it can be automatically converted to new version, as Yang said. Have you checked it, or you just guess it?
Oh, are you asking me?
Yeah. You.
This is from the my memory when I did the cluster group version update. I remember this being the case, but as I said, I needed to double check this.
It can it will be converted to the newer version if you, for example, but Yang, you just said you can, for example, get a specific version. I'm not sure if this, I don't know how this works, but currently if you apply a V1 Alpha 1 policy, and when you get it, it will return you a V1 Alpha 2 policy.
That's exactly what I'm saying. That's because
yes.
internally it's translated. But what you can do is you can do kubectl get Antrea cluster network policy dot something like crd dot v1 alpha 1 when you specify a specific version of it. Then the inverse of the conversion function applies, and the API server will return you a v1 alpha 1 resource. But I think Tran's question is more like in if we already have a resource in the API in storage, does the upgrade bump automatically converts what's in the storage to a newer version? And if my memory serves me correctly, the answer is yes, but I'm not 100% sure. So this is something that we probably needed to follow up on, Grayson.
Yeah, okay. So I didn't check this like specifically, but during my development, I think it will do the convert. It kind of like will reconcile
the. It will convert the API. Yeah, my question is more for storage, and it's more for how when we can remove the support of the old version. Yeah, I believe both cases it can work by getting the old version and by getting the new version, regardless which version the resource is created. Yeah, I believe it works.
Okay.
Actually, I was thinking, should we just keep the older ports fields there too? Even that means we have two ways to define the layer 4 protocol. But that older way is something more familiar by Kubernetes customers, Kubernetes users.
Do you mean like we still have ports here?
Yeah, that's what I was thinking originally. I'm not very certain. I also hope to learn your thoughts.
That may mean we need to maintain redundant fields, right? And which field will be higher priority?
They don't conflict, right?
I guess they conflict since the ports can define like, no, yeah, I know what you mean.
In that case, we'll just do what we have in right now in the ACMT, where we have the namespace selector and the namespaces field, which they're essentially doing the same thing in some senses, but there are slight differences. So we decided to maintain both of them, which I personally didn't think is a good idea, but for transition purposes, that can be there, so that we just tell user that for the ports and protocols, you can only specify one of them, but not both.
So I think it's more like you have a simpler and more convenient expression with ports. But if you want to do more advanced expression, you can go to a new protocol structure. That's my thing.
To avoid the bump up version?
It's not for that. I just feel probably many people are more familiar with this ports definition. That's my opinion. If they don't have ICMP or IGMP and this, more advanced protocols.
I think the approach can be suggested, summarized as let people that don't need ICMP configure ports as usual, and let's give people that need ICMP a new way to configure policies.
So their relationship is will be merged, right? People can either set port or protocol, and if they don't conflict, both ports defined in ports or protocol will be effective. If they are duplicate, then it doesn't matter anyway, right?
Yep.
I think it's pretty easy to fail the transaction if once someone specifies TCP like conflicting TCP data in a policy. It's not a big deal, and usability wise, it's maybe better.
Yeah.
Okay, can I just ask if we can defer this conversation to GitHub and continue with the presentation? Otherwise, we might not have time to complete the program that we have for today.
Sure, works for me.
Yeah,
Okay.
sounds good to me.
Okay. So for the agent side, it won't be too hard since the OVS already has the ICMP support, and also the on the OFNet and the libopenflow also implement the interface for ICMP protocol. The only thing we need to pay attention is our conjunction match. As you can see, our conjunction match currently, for example, you have one kind for the source, one kind for the destination, and one kind for the service. And the relationship between those kind is and. You have to match the source and the destination and the services. But the relationship within each kind, for example, the TCP port 80 and TCP 443, the relationship is OR. But we need and relationship inside each kind, which means we should support a multi-match key and value pairs to support ICMP type and the ICMP code. As you can see, if current implementation, if we do this, it will match the ICMP type is 8 or ICMP type is code. ICMP code is 0. But what we need is we need ICMP type is 8 and the ICMP code is 0. So in this case, we need to change our conjunctive match struct from one key value pair to multiple match pairs. Like we can input like the first one's match key is ICMP type, the second pair is ICMP code. So we can have a multiple match pair. This is the main change on the agent side is required. Somebody else question in the chat? Anyway, okay. So I have a demo video to show you guys how this thing is. Okay. So we have like a client and two server pod here. If we use the client server to call the server, it can work, and ping the server also works. So let's see. This is a V1 Alpha 1 policy looks like. The version is still the old version applied to the client, and egress to server, and we define the ports 80 since we the default protocol is TCP. if we apply this policy, when we try to get it, as you can see, it has already been converted to V1 alpha 2 policy, and the ports is converted to protocols. Let's see. So after this policy is applied, the let's see the quick note here. Since this video is made before flexible pipeline, so the Antrea policy egress rule table is still in the 45. So you can see the service conjunction match is here, and the core traffic is has been dropped. So let's delete this policy and try to apply a V1 alpha 2 policy. So this is a version and protocol we defined ICMP type 8 code 0, which is a ping request. So yeah, it's already V1 alpha 2, no convert here. And can see the OVS flow. It's a ICMP type and ICMP code here. So curl is not work. And ping is also not work. Yeah. So this is the quick demo video. So yeah.
Thanks.
Any questions?
Yeah. Thanks a lot, Grayson. That was a very nice demo. And so I think now the next step is to finalize the discussion on the on the shape of the API. I do not think that these impact has any impact on the remaining implementation. It's just about how to expose the feature to users. In terms of roadmap, is this something that you are planning for 1.7? Is there still any open technical item on this feature?
Open technical item?
Yeah, I think something else that is still being implemented, or is the POC code that you have like providing all the support?
The POC is already in I guess the whole development is in quite good shape. Only issue is if we use reject action on the ICMP, the reject response return to the client, but the ping according to the TCP dump, the reject response has already arrived at the client, but the ping doesn't know this is reject response for my request. I have tried to use IP tables to do the rejection, but still cannot pair the request and the response. I'm still working on this issue. Since the IP tables reject, it's also cannot work. So I guess it's not a rejection implementation. I guess this is the only thing left on the development side here.
Thanks, Grayson. Is there any question for Grayson, and any comment regarding ICMP support in general?
I have just a quick comment that if we go with the approach that Junjun proposed, that we
You mean add a port here?
Yeah, then maybe we don't need to bump up the version, because we can convert the new field in Antrea controller anyway, but when it can convert the protocol field to port field in control plane API. So I guess there's no need to bump up.
Yes.
CID version.
Yes.
Also, quick words. I've looked it up, and I do apologize. It seems that for the originally created resources, if they were ever created at some storage version and you change the storage version, it will never be automatically converted to the newer version. It is only when you update the resource, then it writes it in the storage using the newer version. Now, the norm of deprecating it, I think, is for a really long time, you mark the resource as served equals true, but you put a deprecation notice on it so that whenever people, update the resource or try to create a resource using the old version, they get a deprecation warning saying that this version is deprecated, and you probably needed to wait long enough for all people to migrate the resource to a newer version. Then you basically remove the version for real. So it's going to be a long process if that's the case. Does that answer your question, Trent?
Yeah. Thanks for confirming. Yeah.
Thanks, Yang, for checking that. Thanks a lot. And if there are no additional questions for Grayson, I will move to the next topic in today's agenda. Okay, then it seems that it's all for ICMP network policies. So we'll follow up on how to shape the API for including these on GitHub. Now,
I will post this update on the GitHub. Yeah.
Thanks a lot, Grayson. Now, Lan, up to you for multi-cluster network policies. Thanks for waiting.
Sure, no problem. Let me share my screen. Can you see my screen here?
Yes, we can.
Yes.
Okay, great. I'm not sure if if everyone know that that we have Antrea multi-cluster support since 1.5, and this is actually advanced feature. It's about data path connectivity, and I'm working on this design and the implementation. Because we already have something in 1.5, so before I jump to this connective design, I like to show you that some basic ideas we used during the data path connectivity. And here, that we have a doc about the subfolder multi-cluster folder, and it's all about multi-cluster. And in multi-cluster, we have some basic pipeline, which we will introduce those different resources between between the member cluster in our class sets. And this is a basic, which we will also reuse it in the data path connectivity. Yeah, just remind you that if you are not so familiar with multi-cluster architecture and some terminology, I might be used in following a demo and showing meeting, and you can check here and to see what kind of thing you you can learn. Okay, sorry, let's go back to the data path connectivity design. And the first thing is that, that in 1.5, we allow user, once they set up the class set and join some different member clusters, and they can share or they can export and import different service in our class set. Then they can communicate and access the exported service from other member cluster. This is the original purpose of this multi-cluster feature. But in 1.5, there's a limitation that we need to the underlay network to make sure that the pod or network access or connectivity is supported in underlay network. Which means if there is not supported, then actually our multi-class feature will not work. So in this phase, we are going to supports the data connectivity, data path connectivity. So even the underlay network cannot support the pod IP access directly. We can use this data path feature to allow the multi-cluster service or pod access. Here in our data path design, actually, we introduce a new idea about that is a gateway node. This gateway node is actually, you can think that one general node in a cluster, but you pick up, you assign and treat it as a gateway node. This node will be responsible for all cross-cluster traffic. As long as the traffic will be forwarded to the other member cluster, then the traffic will go to the gateway node first. Then it will be forwarded by this gateway node to other member clusters. So you will see that we have gateway node, and you know that during the data path connectivity, we need to make sure that the member cluster know each other's network information, like the pod CIDR, the service class IP CIDR. So we need to exchange this kind of information between different member cluster. So we reuse the resource, we call the resource exchange pipeline, which we introduced in 1.5. And I will give you a common idea about this later. And in this design, we have two new CRDs. One is tunnel endpoints. This actually represents a gateway node, and it will have some basic information about this local member cluster, like the pod CIDR used in each node, and also the service class IP CIDR. And another one is tunnel endpoint import. You know that once we have a tunnel endpoint resource in our local member cluster, our multi-cluster controller will be responsible to do the exporter role, and it will export the tunnel endpoint to the leader cluster. Then other member cluster will watch this kind of resource import and import it as a tunnel endpoint import in another member cluster. Okay, let me move forward. And you know, I just mentioned that we are reuse the resource export import pipeline, which we introduced in 1.5. You can just you know that we have besides the class member cluster, we have leader cluster in our class sets. You can consider that leader cluster is responsible to exchange information between member clusters. Once we have the information being exchanged in each member cluster, the data connectivity will not be impacted by the leader cluster. The role of leader cluster just help us to exchange those information like the tunnel endpoints resource and another resource. Yeah. And okay, let's move forward. The data path connectivity. Here, I just mentioned that we introduced a new concept about the gateway node. It's just a general node, but we pick up it as our gateway node. It will be responsible to transfer, to forward all the cross clusters traffic to other member cluster. Here, as you can see, in cluster A, there is a gateway node. And in class C, all of the member clusters will have a gateway node, and all other nodes will be just a general node, and it will not talk to other member cluster directly. You will see that any traffic cross cluster will go first to the gateway node, and then it will be checked by our Antrea agent and decide if it's cross-cluster traffic. If it is, then it will forward to another node, the remote gateway node, based on our open flow rules. Yeah, this one you will see it will be forwarded to class C, and if the pod is trying to access some IP or the service in cluster B, it will forward it to class B and gateway node as well. All the traffic across cluster will be go to the gateway node first. Yeah, okay. Here is some TRD details, and the TANA endpoint is actually it's not a complicated. The basic information is about the local class IP, sorry, ID, and then the name is actually usually it will be the node name. The subnets is what we talked about. It's a pod CIDR used in each node, and also the service cluster IP CIDR. And this private IP and public IP represents the gateway nodes as IP, and is we used to, when we set up some tunnel open flow rules, we need the target IP, right? So we will choose private IP or public IP to do the rules. Okay, this condition. Another part is another CRD is the tunnel endpoint imports. This resource is actually almost the same as tunnel endpoint, but the purpose is that it tells the user or the mainnet is some tunnel endpoint from other member cluster. It's not a local tunnel endpoint, and it's also almost the spec is almost the same. We just reuse the tunnel endpoint spec because all we need to know is remote the other member clusters pod CIDR and the service IP CIDR, so we can use it during our OpenFlow to set up our OpenFlow rules. Okay, the tunnel endpoint export import process, this actually is almost the same as the service export import process. So it's not, it's actually quite straightforward. It's just, let me simply go through it. You know that once the user choose a node as gateway node, here the way to choose a node as gateway node, we just simply add an annotation. Here is a gateway annotation, and to the node then our multi-class controller will watch this kind of node event, the update event. Then the member cluster's controller will create a corresponding tunnel endpoint to local. And you will see a local tunnel endpoint resource being created, and including those necessary information. And of course, it depends on the what kind of node change. If it's a gateway node, it will have some basic steps to create a tunnel endpoint. If it's a general node, it means, for example, if there's a new node coming, then we know that there's a new pod CIDR will be used in this member cluster. So it will be also reflected in our tunnel endpoint subnet. And okay, when the tunnel endpoint is created locally, then the multi-cluster controller will watch this event, and it will follow the resource exchange pipeline and wrap it into our resource export resource in our leader cluster. Once leader cluster saw this kind of new creation event, it will convert it into the resource import in the leader cluster. So actually, when the new resource import is created, then the member cluster, the other member cluster will watch this kind of events in leader cluster. Then it will convert it and write a new tunnel endpoint import locally. It's maybe if you're not familiar with the framework of multi-cluster, might be not so, might be some be confused. I will show you in a demo, and it will help you to understand it better. Okay. And you know that so once we have data path change, we have to do something in the Antrea agent. So we introduced a multi-cluster feature, and in the Antrea agent configuration, and here I just add a new feature here named multi-cluster, and also a necessary new global virtual MAC. It will help us to distinguish the cross cluster traffic. And in our current design, you know that we plan to support the in-cab mode only, at least in first release. So we will reuse the existing tunnel interface, and it's so we don't have to create another new tunnel interface for cross-cluster traffic. Here is actually some sample, the OpenFlow sample, which is working, and it's some snapshot from my POC code, and I think maybe we don't have to jump to the detail. My one thing might be highlight is that there's a new field this about the import will be used, because once we reuse the existing tunnel interface, it means some traffic will go this tunnel, and it will also be forwarded in this through this same tunnel. So we need to use this field to make sure that the same traffic can be forwarded in the same tunnel interface. Yeah. Okay, I think that's all the this simple OpenFlow rules. But okay, there are some roadmap. You know that there in this design actually there are also limitations. We didn't support the IP overlapping. So once you have overlapping, I think the behavior is not will not be supported, and we want might be the network communication might be broken. And so in the future, we may support IP overlapping. And also, you know, in first, in this design, I just reuse the tunnel interface, and we will use the default in-cab mode, the Geneve. So in the future, maybe we can introduce IPsec and also the class set DNS. Because even we have the data bus connectivity, we can communicate between each pod or service, but you know, it's not so common use to use the IP directly. So it might be better to have a DNS in class set wider. Yeah. Okay, let me go and sorry, let me stop here, and let me share my demo screen. Let me know if you have any question so far.
So now for IP overlapping, you mean the port IP or node IP?
I think both.
Why we cannot support overlap IP?
Pod IP is first. I'm not sure. I haven't think about the node IP, but if it's node IP, if they're the same, I don't think it will work.
No, I mean port IP. What's the issue with overlapped port IP?
You know that. Let me go back to the. Sorry, let me go back to the design. Can you see my screen? I'm not sure.
So it's I can see your console, but not the slide, not the doc.
Okay. Actually, let me stop here. Let me share my screen. Okay. Let me
still the console. Here. Okay. Okay.
Yeah. The reason is we didn't exchange pod information. So in OpenFlow rules, we just use the CIDR to decide if this pod, if this belongs to the remote cluster or not.
This is a class IP,
right? And also pod CIDR IP.
Why we have a traffic directly to port IP? I think it's for multi-cloud service, etc. Oh, you're saying we want to support the direct communication between ports?
Yeah. This actually they can do the same. The mechanism I think is almost the same. So we can remove this or we can add them.
Okay.
Yeah.
Okay.
Okay. Let me go to I have two cluster. One is you can see it's a C1 and another one is C2. And the C1, it's we allow to deploy both leader and the member cluster in one cluster. So in C1, it will play as a leader and also member. Let's go. You'll see that in leader cluster or leader namespace, we have one multicast controller, and in Kubernetes system, we have another controller. It plays as a member. This one is leader, and it will watch our annotation for the node and will create tunnel endpoints. For now, and I already have some. I already created or a node pick up one node as gateway in C2. So you will see, oh, sorry. You will see there's already one tunnel endpoint. I choose this node as the gateway node. And in cluster one, you will see that sorry, there's nothing. So I will choose one. Let me show that we have 3 nodes in this cluster. I will choose this one as node cluster, just simply run annotated and add a new annotation. Then our multicast controller will watch this kind of a node change, and it will create a new tunnel endpoint. So you will see that we have a new tunnel endpoint in the member namespace. And let's go to see the export resource export and import in our leader cluster or leader namespace. Here in our leader namespace, we have one new resource. This actually new resource export a few seconds ago. And this one is new created one. And let's go to see the yeah, you can see that it's actually almost the same, just a different result, but the content or the spec is the same because we only want to get the pod cider and the service cider right. And eventually the member cluster, the C2 member cluster will get the notification of this creation, this resource import creation, and get a new ton endpoint imports. It will create locally. Then once we have this being ready in local, then the Antrea agent will watch this kind of change. And let's go. Let's see that. You'll see that the critical information is once, of course, all critical, but we are more concerned about the private IP for remote tunnel setup and also those subnets used in C1 member cluster. Let's go and see. Go back to see. It's actually almost the same. You see here, it's a private IP and the subnet IP. It's being imported in C2. Then let's go and try to maybe let's go and get any pause here, and let's pick up one. I have a few pods which can help to try some command here. Yeah. Okay, this one is in C2, and let's ping another. Okay, we have the IP. Okay, now you can see the IP here. We have the CIDR is totally different, and there is no overlapping. Then let's go and ping this. Yeah, you can see that we can ping pod successfully. Let's go and guess. Okay, this is Nginx. Let's go and. Yeah, you will see that we can communicate to the service directly. But as I said, we use IP, right? The ideal way, I think it's better to use the DNS, but for now it's not so ideal. But the data path connectivity is working now. Yeah, I think. Sorry. Okay. Yeah, I think that's all for my demo and the design presentation. Let me know if you have any question. Or...
Yeah, thanks a lot, Lan. We don't have a lot of time for questions. There are some comments from Junjun on the chat that maybe we might want to discuss. The only thing that I wanted to check with you, just out of curiosity, is that whether we need then another controller for managing gateway node failures and doing a gateway failover, or whether there is already a solution for that in your implementation.
Yeah, that's right. You mean that when the gateway node is failed, how we handle this case?
Yes, yes.
Actually, for now, we only support one gateway node. So when the gateway node it's not work, it means the traffic will not be able to forward to other member cluster. But in the future, we may consider to support active mode. Then we can maybe have two gateway node. Then we may have a robust case.
Cool. So let's say that at the moment, once a gateway node fails, it's up to the user to designate a new gateway node and restore communication.
Yeah, I think so. But if there's not accessible, the gateway node is not accessible, then I think maybe we can update the Tana endpoint resource to reflect some events or the status. But indeed, at least there's no automatic way to recover the traffic.
Got it. Thanks.
Okay.
Yeah. Any other question? Maybe we can spend a couple of minutes more. I think Janjun has a point about the needed support non-in-cap mode to cover cloud managed scenarios. Maybe Janjun, do you want to elaborate a little bit on this comment?
Yeah, I just mean later probably we want to also support EKS, AKS, GKE. In this case, they don't do in-cap mode inside the cluster. So we need to think about how to support that.
Okay, sure.
Thanks.
And by the way, for gateway mode, I think finally we need to support ITI active, not just ITI standby implement. Since if the single node, it can become a bottleneck.
Yeah. Okay, I will check that if we can support this in first release.
I don't mean we must prioritize it, but I
Okay.
just feel finally we need to think about ITI standby story.
Okay, sure. Yeah, that will be in our multi-cluster to-do items.
Okay, and just to finish today's meeting, what we've seen today is currently planned to be shipped in Antrea 1.7. Is that correct? Hey, I don't know if you could hear me. Oh, okay,
yes,
thanks, Vicky.
so I think yes. The release note has been submitted for review. So I think maybe today or tomorrow we can announce Antrea 1.6 is released.
Oh, okay. Oh, sorry. So this is for Antrea. This feature is available in Antrea 1.6. Then I missed.
No. You mean this
okay.
feature? Oh,
yes,
I just maybe I misunderstand your question. Yeah, I just now I said is Antrea 1.6.0 release status. Yeah, but this feature, I think the plan is to support it in 1.7, but
okay.
But not sure. I think it is a stretch goal to support it in 1.7.
All right. Thanks a lot, Vicky. Thanks for the clarification. And do we have any other questions? Yeah, go ahead.
Lan, quick question. Can you clarify the difference between public IP and private IP in the tunnel endpoint specification?
It's actually from the node spec or node status. I think it's from the node information, not any specific meanings.
Oh, I see. But it seems to me that the private IP, maybe it's only routable within that cluster, right? So I'm not sure how you could use it to create a tunnel. Right. Maybe missing something.
Yeah, that's actually a question, a good question. You know that in my local cluster, I tried that. I didn't see any public IP, so I have to set the private IP here. But I guess we can pick up the public IP first, and so make sure that they will use the public IP.
Yeah, because I think if you're in the
choice.
public cloud, for example, if you're in the same VPC, maybe the private IP is routable. But if you have clusters in different VPCs or even different clouds, then you would have to use a public IP.
Yeah. Thanks for reminding. I will try that. Maybe I should try that in different environment to see what will happen here. Yeah, thank you.
Okay. We are already a little bit over time, but nevertheless, it's been a great discussion. Before we finish today's meeting, do we have any final question for Lan? Any comment on the whole multi-cluster data path story? All right, it seems then therefore it might be all for today. I would like to thank, as usual, everyone for attending, and most importantly, many thanks to Grayson and Lan for providing two very nice presentations and demos. So thanks again for attending, and I wish everyone a good night, good afternoon, or a good day.
Thank you.
Thank you. Bye.
Thanks. Bye-bye.